How do you know your architecture fits your business needs? This is a very difficult question and one of the most important questions you need to ask, particularly in the age of AI-assisted software development, where you can create a lot more code much faster, but the architecture is not necessarily the right one. So let's talk about it. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to talk about my favorite superhero, which is the mask, because he's always ready for a party. Oh, sorry. I think we are not talking about this. We are talking about evaluating architecture. And let me show you what I did. This is a mental model that I tried to systematize in this diagram. First of all, the important thing about architecture is that it starts from artifacts and hypotheses, and it ends in production in the real world. So what we have is a bunch of phases. You have, let's say, a design time, roughly speaking. You have a build time, you have a run time, and then you have a production. And you can evaluate architecture at all these levels, but the only time you actually know that the architecture fits what you need or not is when it runs in production. Until then, what we are doing is trying to evaluate various artifacts and to test our hypothesis, to stress test our hypothesis in order to ensure that we do not go on the wrong path. And we sometimes do, and then we need to modify the architecture. That's a given. Another thing that I'd like to discuss is that there are two big approaches to look at the architecture. One is structural. You look at the structure of the code, the structure of the modules, the structure of the communication, and you evaluate that. And then there's behavioral, which means how does the architecture behave when running? Is basically static versus dynamic, or structure versus behavior. How it behaves versus how it is structured. And now let's talk about how we can evaluate. First of all, we have these steps, the phases, a design time, a build time, a run time, and in production. And then we have ways of evaluating. Manual inspection, tool-assisted, AI-assisted, which is a newer one, and fully automatic. And let's talk about some ideas for these different phases and types of evaluation. So if you are a design time, you can probably do an architecture review, you can do an ADR critique. This is mostly on artifacts. You have diagrams that you can review. You can do with modeling tools if you want to do tool-assisted. If you're doing AI-assisted stuff, this is where it gets interesting. You can create the architecture decision records and critique them with AI assistants. You could generate diagrams and critique them with AI assistants. You could also generate a prototype and critique it with AI assistant, or generate the prototype, run it, see how it runs, measure stuff about it. And at this level, there's very little fully automatic tools that you can use. At the build time, you have, again, manual, you have core review, you look at the code, in this case. Tool assisted, you'll have tools like SonarQube, but then you have some more interesting tools like ArcUnit and then contract tests. So ArcUnit is basically tests on the structure of your architecture. Those tests validate that part of the code, for example, code from one module is not calling the internals of another module. These are tests that you can write with ArcUnit. And contract tests are about the behavior, is how a module needs to behave when taken in isolation. So assuming you get the right inputs, what are the outputs that you need to give back. This will be tool assisted. If you do AI assisted, you can do AI code review and AI test generation here. And the fully automatic parts are static analysis gates. You can run various, in your continuous integration, you could have a step for static analysis, and if values are not correct, then it gets blocked. And you could also have the automated contract tests as part of your continuous integration that block progress unless we fix the contract, the implementation. Now, in terms of runtime, you have exploratory load testing and manual chaos engineering. This is when you try to load the application with various types of requests and see how it behaves. And with chaos engineering, you start taking down services or introducing latency or taking down the database of the network and see what happens. And this is something that you can do manually in the first phase and then do it automatically later on. For tool assisted, at runtime, you can do load and security test suites. This can be automated with various tools. And then AI assisted, here it's a very interesting thing because you could generate AI tests for security, for performance, for load, for a number of things. And then what you have as fully automated is, let's say you did a bunch of experiments here, but you also automated them and you end up with automated performance and chaos gates. You could even automate the reliability tests, the chaos engineering part. And then when you go in production, what you have is manual stuff like architecture retrospective. You look at the architecture and how it behaves and you review it. You review the incidents. This is a very important part because part of the feedback is the bugs. If you have incidents, some of them can be functional, some of them can be non-functional, and you review those incidents and see what makes sense, whether you can fix something from your architecture, whether your architecture is fit for purpose. That's the whole goal. And then you do tool assisted. This can be dependency driven detection. So for example, are modules calling things that they were not supposed to call? You can have dashboards and tracing that show you how the system behaves under load, under denial of service, under various constraints, but this time in production. You gather the data, you look at it. And then at AI assisted level, you could have anomaly explanation, something called AI ops. Basically, you use AI to try to explain these issues and see whether you need to fix your code in any way. And then fully automatic, what you have is various alerts, various warnings from your dashboards that send you, something is not working and so on. And this needs to be part of your architecture retrospective. Now, how you apply these things, you apply them on the most important non-functional requirements. So when you look at your architecture, you need to figure out which are, first of all, the non-functional requirements that are relevant for your architecture. Typically, you have the big four: performance, scalability, reliability, and security. But then you may need to add a bunch of others. There are probably 40 non-functional requirements that I know of. They include things like archivability, internationalization, the ability to audit parts of the data, all kinds of things. And based on this analysis, you figure out which are your non-functional requirements, and then you need to prioritize them and to see which of the non-functional requirements you need to pay more attention to because you need to implement them at a higher level than usual. And those are called called architectural concerns. And when you deal with these architectural concerns, these are the ones that need to be really validated. So for example, if you if you need reliability, usually you have 3 nines reliability, and that works for most of your products and it's easy to implement. But for this particular system, you need to have 5 nines or 6 nines of reliability. Then what you need to do is to pay more attention to it. So you end up with this whole process that you need to go through and see, well, what fits and what doesn't based on the constraints that you have. Of course, this topic is extremely complex and extremely contextual because architecture is very contextual. It's about how the code structures fit your business needs and not about how it works with other organizations and so on. Architecture is very contextual, at least the things that matter are extremely contextual. So because of this, you need to make a lot of local decisions. And those are important skills for an architect to understand. But this is a mental model that maybe you can use, modify, and apply to your architectures. Or if you need some help, let us know, and we'd be happy to discuss collaboration. This is all for today. If you find this interesting, please let us know. Leave us a like, share, subscribe, leave us a comment if you have questions. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.